Hello, and welcome to the Computing Conversations column. This column is from the January 2015 issue of IEEE Computer and is titled Khan Academy in Computer Science. There's supporting video material for this column that you can find in the IEEE Computer Society YouTube channel or in the IEEE Digital Library. I'm the editor of the column, and I'm Charles Severance from the University of Michigan. Khan Academy was founded in 2006 when Salman Khan started recording short lectures on basic mathematics and uploading them to YouTube. Over time, these lectures expanded into new areas including history, medicine, physics, and economics. Software was also added to help track students' progress toward various learning objectives. Khan Academy is a very valuable resource for students of all ages and those needing remedial education. In 2012, computer science was added to the list of topics. I spoke with software developer John Resick, who created the popular jQuery library, and curriculum builder Pamela Fox about Khan Academy's edition of computer science. John initially joined Khan Academy to help develop its software platform, but he wanted to help when Salman and others started thinking about adding computer science to the curriculum in 2011. While working on jQuery, John interacted with some of the most talented software designers in the world. But to understand how a learner might approach computer science with no prior knowledge, he revisited his own early experiences with programming.
I was a teenager, maybe about 14 or 15 or so, and a friend of mine came over to my house, and he had a floppy disk, and on it was a copy of QBasic with a program or two. And he's like, you need to try this out, check this out. And he loaded up and he ran some program that he had written. And it was just a very basic, it may have just printed something out, I don't remember. And I remember that was the first time that I didn't realize that you could actually tell a computer what to do. I wanted to try and sort of take that initial experience that I had personally and the sort of experience of being able to read and learn and try things in an open environment.
Even though the Khan Academy program is called computer programming, it's not meant to be equivalent to a college degree in the subject.
It's not what most people think of as a computer science curriculum. We're not, at least at this point, we're not going to replace a CS 101 at a university. And a lot of what we're doing is encouraging students to do that exploration for themselves, to be able to look at code, see programs that other students have written, that we've written, or whomever. And I feel like the most important thing that we could do is be able to create that little spark.
John built an environment that enabled experimentation and sharing, and Pamela added curriculum and educational materials to the environment.
Computer programming was a playground, and it was great, and people were creating, there'd already been millions of programs created at that point, I think, but there was not much of curriculum around it, and so it meant that I was worried that we might lose some people who weren't able to figure it all out just by exploring, just by the tinkering, who didn't need to be explicitly said, this is how a for loop works, this is what a variable is, now you try it. So what I did was when I started off, I took my JavaScript 101 curriculum that I'd been giving in traditional classroom settings, somewhat traditional settings, and then codified that. And that meant creating talkthroughs, which are like videos, except they're way cooler because they're actually the editor on the left-hand side and the output on the right, and you can actually pause, and it's the actual live editor, so you can then make little changes, see how it happens, and then you can continue playing.
Pamela also created auto-graded coding challenges and peer-graded projects that are somewhat open-ended to help students assess their progress and mastery of the materials.
And the coding challenges are step-by-step, okay, we want you to do something like this. Okay, you're close, but you've actually made this common mistake. Here's maybe what you should do instead. And it's a way of both assessing and giving them a way to practice and teach them a bit more. So for every talk-through, there'll be a coding challenge. And then every so often, there'll be a project, which is this bigger free-form creative project, which is gives them a lot of freedom for what to do while still practicing what they've learned. So maybe they're making a fish tank once they've learned functions, and they have this fish function, and they have to parameterize that function so that fishes can have different colors or sizes, right? But they can go wild with that. They can add seaweed, bubbles, whatever they want to do, and sometimes they even make rat tanks.
The goal is to focus on the initial experience of learning to program as early as possible in the K-12 curriculum.
Maybe 6th grade is when you start learning to program. So you learn the basics of, some language like JavaScript. And then you start making your own programs. And then maybe you start making programs for projects in other classes. And I've seen this with some of our students, is that they use it for science fair, and they use it for their history assignment. They use it to make a timeline. So they start using programming to complement those other classes or those topics, because that's one of the big things, is that programming, it can be very cross-disciplinary and really work together with other stuff, and we don't necessarily want everyone to become a computer programmer. We want everybody to have that as a skill in their toolbox. And then, the other thing is that as they keep going, as they're making programs, we really want them to be working with other people in making programs, because that's one of the big things about software development that they don't even really teach you that much in college, is that it's a huge team effort. Right? And if you're really going to make a good piece of software, you're going to have to work with other people. And it requires a certain amount of skills, and it's also a really fantastic experience to work with other people. It's way more a collaboration than a competition.
In addition to teaching programming, the Khan Academy Computer Science program aims to prepare students for a career in the field. It's a challenge to succeed if the students take their very first programming class in college. John recounted his high school experience with programming.
I remember I was taking an AP computer science class in high school, and I had also been in other AP classes with my other friends, like AP English, AP History, and they were smart. I knew they were the smartest people, and they could go to any college they want. And we got to AP Computer Science, and I was just like, I could just do whatever. I knew exactly how everything worked, and they struggled. And what was interesting for me in seeing that is I realized that there are certain concepts here that are challenging, but potentially if they're taught in the right way, that these people who I know are really smart, that they should not be struggling, that they would be able to get it.
As the Khan Academy Computer Science curriculum is developed, it's important to get feedback from students and teachers working with the materials.
Getting to see classrooms use your stuff is incredibly valuable. So anytime I interact with teachers, I always come back with feature requests. And we came up with new teacher tools for that. So teachers now have a much better dashboard to actually monitor the progress of their students and see where they're at in the curriculum. And they can actually see roughly who's at what spots in the curriculum. So they could kind of say, oh, these people should help each other, or these people should pair together. And they can see all the programs that people have created. And it's very interesting because at this high school, there's this teacher, Ellen, who's teaching using our platform, and then there's another teacher who's teaching using traditional processing, which is the desktop Java version. And when they do their assignments, they have to zip them up in a file, and they have to email it to him, and he has to go through them and rate it that way. And whereas Ellen just reloads the programs page and can see exactly what her students are working on. So it's kind of streamlined that part of it too.
If Khan Academy is successful in expanding the number of students exposed to programming during their K-12 education, it'll be interesting to see how computer science education in college will be influenced by a larger pool of incoming students with a strong understanding of programming principles. This column is from the January 2015 issue of IEEE Computer and is titled Khan Academy in Computer Science. There's supporting video material for this column that you can find in the IEEE Computer Society YouTube channel or in the IEEE Digital Library. I'm the editor of the column, and I'm Charles Severance from the University of Michigan.